Good morning. Welcome to this webinar. Today we are talking about megawatt charging. My name is Niklas Schmalotz. I'm representing Polish Network, and we will share with you some of the work that our project partner, as part of the NextETRUCK project, is working on. Our project partner is called JEMA, and today our colleagues from JEMA, Ivan Chero and Miriam Azumendi, will share with you their work and the insights and a little bit about the NextETRUCK project. So I would just like to give you some very basic rules of the webinar. This webinar is recorded and will be made available afterwards on nextetruck.eu. This is our main website for the project. And if you have any questions, please state your questions in the chat. And also let me know in case you cannot hear us properly or there are other problems related to audiovisual challenges. So by this, I will give the floor now to my colleagues from JEMA. So please share your screen.
Okay, just a few moments until we share the presentation. Okay, first of all, thank you, Niklas, for giving us the opportunity to share with everyone what we have been doing during the last couple of years in the NextETRUCK project. Okay, but one thing is to demonstrate the next generation e-mobility concepts, or wanted to play a pioneering role in the decarbonization of the vehicle fleets, which are the two main objectives of the project. But let's say, is it truly a feasible goal or just a dream to decarbonize or the next generation e-mobility concept? Do all heavy-duty industry vehicles have the possibility to decarbonize? We are talking about long-haul, marine, air, mining, and one of the let's say last questions is: are governments really on board with going green? So during the next minutes, we will try to answer all these points and others that may arise that you may have. Starting, one of the key aspects why decarbonization should become a reality is that at European community level, reducing the emissions by at least 55% by 2030, it's a legal obligation. What's more, EU countries are working on new legislations to achieve this goal and make the UE climate neutral by 2050. So this initiative is called Fit for 55. Which is a set of proposals to revise and update the UE legislation and to put in place new initiatives with the aim to ensure that EU policies are in line with the climate goals agreed by the Council and the European Parliament. Putting in more mundane words and focusing on electrification, Fit for 55 calls to have enough recharging points for alternative fuels for the cars, planes, ships that may use them. As you can see, transportation is responsible for 25% of the world's greenhouse gases. So during the next slides, we will cover the status, needs, or issues of the different means of transportation. Okay. To boost the long-distance road transportation, the European Commission has proposed distance-based targets along the TEN-T network, which links major cities and nodes around Europe, as you can observe in the picture. Let's say, as you can see in the table, there are different concepts inside of the TEN-T. The two main ones are the global, which is a broader concept of the network comprising all elements considered to be common interests for Europe, and the core elements are network concepts that are the highest strategic importance for the Union's transport policy. As you can see in these two structures, it will be necessary to have charging stations every 100 kilometers with at least a charger of 350 kilowatts and up to 1.4 megawatts or 3.5 megawatts, depending on the year. As you can see, it's a very ambitious goal, and with projects such as NextETRUCK and others that are working on other charging infrastructure companies and other OEMs, may be easier to achieve this kind of goals. Okay, so changing to the next charging, to the next means of transportation. According to the European Commission, new clean technologies such as electric or hydrogen aircraft are not expected to be mature enough to play a significant role in a commercial aviation in the coming decades. However, Airbus and other big companies disagree with this statement, and they believe that electric and hybrid propulsion is rapidly revolutionizing mobility technologies in all sectors. And this would mean the biggest revolution in aviation industry since the invention of jet engine, which, let's say, it's a big statement from their side. However, let's say the first steps in electric passenger flights, the first plane was called Alice, there were some problems with the batteries. They were too bulky and heavy, and let's say did not supply enough power for long periods of time. This first flight was just of 8 minutes. So just, let's say, put it in other words, it wouldn't made any difference in the commercial flights. There is no flight of less than 8 minutes. And let's say for the company that produced Alice, they drastically reduced the expected distance that the plane could fly from 815 kilometers to 445. So let's say fully electric flights are going to be challenging, but Airbus and other companies, they are going, let's say, let's go to a hybrid electric concept between taxi, landing, and let's say the time that they are in the airports, sorry. That could be, let's say, the green side of the flight, and the other part they could go with greener fuels rather than the ones that they are using nowadays. Okay, regarding ships or marine applications, we can say that this is the sector in where plug-in technology at docks has existed for more than 20 years. But let's say that only a small number of vessels are currently using it. The three main issues that we have seen for the lack of usage have been the lack of demand, or let's say the classic chicken and egg situation. There are not many ships electrified, so there are no charging stations, and there are no charging stations because there are no ships electrified. The grid capacity. Let's say onshore power requires significant capacity, and ports usually or often have limits on grid connections and limited space to add additional on-site generation. So alternative solution would mean having smart charging or peak shaving solutions that should be analyzed in order to boost the marine application. And also lack of standardization. We have seen that plug-in technology has existed for more than 20 years, but there has been a lack on the standardization regarding interoperability, energy storage, the type of voltage, AC or DC, that needs to be used. So initiatives such as Charin, that we are going to talk a little bit later, could work or could help us, help everyone boost also the marine technology or the marine green decarbonization process. Okay. Last transportation or application that it's aiming to go green, it's mining. Okay, a fully electrified mine with renewable energy sources could mean or could have a 60 to 80% lower carbon footprint, okay, avoiding carbon taxes. The main problem or issues are the charging times at powers that they are asking. And you can observe in the table that you have in the slide, they are asking charging times below 5 minutes with charging powers of up to 16 megawatts. Okay. Nowadays, with later you are going to see with charging initiative, the maximum is around 4 megawatts. So they are asking 4 times more than what we have been working on. Okay, so we have already mentioned sharing. What is sharing? Okay, it is a group that is trying to see that what have been the different means of transport, what the issues for the different means of transportation have been, or the difficulties that they have with the decarbonization process, and to ease that sharing was born or was created. It's a global organization with over 300 members dedicated to promote standards in the field of charging systems from EVs or all types of vehicles all around the world. Okay, so to satisfy at the beginning the market demand on the truck and bus industry, okay, to charge the electric heavy-duty vehicles within a reasonable time, a new solution for high-power charging was needed or is needed. That need was the birth of the Megawatt charging system, or the MCS. Even though it was born to satisfy the truck and bus industry, it has been seen that we can use it in the different applications that we have been talking in the presentation, the marine and the air, or even the mining. Okay. The main characteristics of the MCS, you can see them in the slide. Okay, it's that the voltage will go up to almost 1300 volts. It was at the beginning thought that it could go also at up until 1500 volts, but at the end it seems that it's going to be 1250 volts and up until 3000 amps. Okay, but let's say we will have different plugs, three levels of plugs. The first one is going to go up until 350 kilowatts, which is similar to the HPC that nowadays it's in use, and it's a CCS standard with refrigeration. Then we have a level 2, which is a 1.2, 1.3 megawatt charger. It's a 1000 amp charging system. And the last one would be a 4 megawatt charging system, or 4.5 megawatt charging system with 3000 amps. Okay. The standard that it's going to follow, it's the ISO 15118-20 that was published around 2 years ago. There have been some testing and everything with the plugs, the protocols, and everything. It's going to be cyber secure, which is a topic that it's nowadays really important, and it's also going to be bi-directional. It's going to allow users to go bi-directional. This is, let's say, the actual situation, but where are the charging infrastructure companies like us, or the OEMs that build trucks or buses? When are we expecting to share or to start the production of this kind of chargers? Most of us, some of them are going to be faster than others and everything, but the aim is to go during the second half of next year, 2025. The first vehicles, pilots are going to start testing and everything. So we can hope that at the end of 2025 and also and for sure 2026, it's going to be, let's say, the big boost for this kind of technology, and hopefully for for the decarbonization of the transport all around Europe and also the world. And with, let's say, these slides are the end of the first chapter. We have a small video that will give you a little bit more of an insight on how we think that the NCS can work, or what kind of applications can be used in, that we are going to share. And then we are going to have a small Q&A section for this first batch of slides. And afterwards, my colleague Yvonne Cerro will continue, let's say, with how we apply in JEMA all the knowledge that we have in the MCS for giving you or for giving our customers the best solution possible.
Okay, thank you, Miriam. Now we are going to show with you the video. There are 3 different applications for the MCS, or where the MCS solution could be applied. It's our view is not, it could be 3 of the multiple choices that could be in the future, but at least are the 3 ones that we think that we see it, let's say, more likely to be in a short, medium term. There is some audio problems, so the music, I think that we are not going to be able to listen to the music, but all the messages and all the information, it's written down in the video. Okay, so let's see the video. Okay, so in the Q&A, I don't know, Niklas, if you I see some message in the chat, but I don't know if there are some questions from the audience or the other comments about the other issues.
I have not received any question, but maybe I can ask a question, and maybe others are encouraged to state their questions in the chat. If you're digging deeper with regard to MCS, what are currently the limiting factors of megawatt charging? If you could maybe, I mean, I think everyone is doing the research, and of course we're all trying to develop a solution, but where do you see the main limitations at the moment?
Let's say what we are seeing are that there are small, let's say, small gaps. Let's talk like that. Maybe regarding the how to apply what the standard says, both in the vehicle and the charging side. But those are, let's say, I think the easiest ones to solve them, which can be a little bit more tricky. It's okay. We are talking about going 1,000 amps, 3,000 amps of charging power. Power electronics technologies already there. I mean, you have different applications that can withstand that power and that they are asking that. So regarding the charging side, there is no more bigger issue. We have seen that there is a small limitation on the batteries are right now not there. And also depending on, the batteries are already not there, and you have to make different changes in the vehicles so that, let's say, the cabling that go between the charging point and the batteries, it also has to be cooled and everything. So let's say it's more how to make those transitions in the vehicle and the batteries that will make the transition faster or slower. This doesn't mean that the vehicles are not working on. We know that there are different OEMs that are working, and they are saying that during next year they are going to have the first vehicles that follow the MCS. They don't say which of the three levels. We are guessing that it's level 2 with 1 megawatt charging or 1,000 amps charging power, because the 350 is already a reality, and the 3,000 amps, I think it's not needed right now.
Yeah, just one to point it out. Another thing also, and fully agree with you, Miriam, but we also make to make some or to take some our attention to the grid connection.
Yeah,
as we are going to be using or demanding from the grid 1 megawatt. I don't know if it's a continuous operation mode, but quite constantly. I mean, it is one bus, then another truck or whatever vehicle we need to charge. We are going to demand to the grid a quite huge amount of energy if this is ramping up in the next year. So it's a stakeholder that needs to be also very involved in order to say where, how, and to solve this issue that's also from the will be demanding to the grid.
Yeah, and also following with that, the idea that Yvonne was talking, as the grid, it's not going to be ready for all that demand. Let's say peak shaving, smart charging, and everything. It's going to be a key role for them. Of course, if you put the smart charging, that means that you are not going to be that you are going to limit the power. So mostly it's going to be go to peak shaving, have batteries, solar panels, whatever you need, so that you can ease what the demand to the grid with alternative power solutions.
Okay, thank you. There's one more question that refers to the video. So Scott is asking, what are the key elements considered as part of the design of the site? I think the site that he's referring to is the one that we have seen in the video. So I think this will be probably presented in the next part when we're talking about the the different elements of the of JEMA, what they can provide, but maybe you could you can maybe elaborate if this is just like a concept that we have seen in the video, or if there are any concrete plans related to that.
The video is just a way to, it was more focused on showing the different applications where the MCS could be applied today. For instance, I think that it was application number 2, it was how to double the shift with some for some trucks that it's very important in order to make the investment work. Okay, so the investment in the trucks, and the third one was for the application in the logistics center, when we think that this in cross-dock stations, where we think that this could be has some good opportunity to use them. Regarding to the chargers, we will show you in the next slides where we are. But let's say briefly, level 1 up to 350 kilowatts, is already in the market with CCS connection, not the MCS, because we are closing these gaps, as Miriam told you before. Level 2 is the one we are working within this project, the NextETRUCK project, and the level 3 that goes up to 4 megawatts is we are, let's say, in the first step of development, still not going to have the level 3 till 2027.
Okay, perfect. Then I think we just continue. And there's one question that just came in.
Perfect.
As we know, there are grid availability issues for MCS. How do you see the BESS support to mitigate the grid availability issue? I don't know what BESS support means, but maybe you know the abbreviation. Yeah, because I'm not a technical expert.
Battery storage.
Okay.
Yeah, storage system.
Yeah, I mean that's mainly what we were what we wanted to tell you, or the idea was of the peak shaving. Of course, you are going to need battery systems that during the moments that the charger is not working, they charge the batteries that you have over there, so that when you need to supply the 1 megawatt power, you have, like, I don't know, 40% you take it from those batteries, and the other 60 you take it from the grid, or from solar panels that are working, or wind application. I mean, you will, or we will, between everyone, we will need to find a solution so that the grid doesn't get congested, which is one of the main problems nowadays.
Yeah, we are facing this kind of projects nowadays. It's true also that there are few ones. Most of our projects don't require us these BESS systems, the battery energy storage systems, but few of them, they are still start thinking on that, and the projects are going on. Of course, it's let's say nowadays it's not a technical issue. It's just from the let's say money point of view, you need to make your own, let's say, calculation and see it's from the market, or from the market point of view or business point of view, your business plan, it's able or not to have this some amount of money for the battery energy storage system. But some projects in some depots, European depots, are already started with some pilot plans integrating this kind of solutions. Yeah.
Okay, thank you very much. I think now we can
You're
go
welcome.
to the next segment.
Okay. Next, now we are going to try to explain to you what our research and solution, and which kind of products we have in order to, let's say, give solution to the MCS project. We are going to explain the different, let's say, roadmap that we have. But first of all, let me introduce the overview or our activity in charging infrastructure that we have for heavy-duty vehicles. In this, let's say, map, you can see at Europe level, that we have more than 1,700 charging points. We are also trying to put the amount of power that this charger requires, and it's up to 1.7 megawatts. Okay, so it's quite 107 megawatts. Sorry, so it's quite high amount of power that is demand from the grid. Of course, not all of these chargers are working all the day. Mainly, most of them are for depot overnight charging systems, so they are working around 5, 6, 7 hours during the night, and 50% of them they are opportunity charges. That means they are located in the road, and during the day, let's say each 1 hour, 50 minutes, a bus or truck arrives, charges from 5 to 10 minutes, and it goes. And this is a 24 hours operation. That means around 24 times charging per day. Okay, this is more or less the data. The major activity, as you can see, is in countries as Spain, France, Italy, or Germany. But there are also some, let's say, interesting projects, maybe smaller, in Switzerland or in Luxembourg, in United Kingdom also, in Portugal or in Bulgaria. Okay, so this is our expertise that we have in this market. And if we come back to the solutions of the products that we have, before to show you the MCS solution, please allow me to recover the actual situation for the CCS systems, where most of the, maybe from the power point of view, they are different from the MCS level, but they have, let's say, the aim characteristics adapted to the MCS solutions. We have power up to from 60 kilowatt up to 600 kilowatts power. So this is the first difference to the MCS. The MCS level 1 is covered with from the power point of view from the actual chargers, not from the communication point of view, of course, not from the plug itself. So there are other differences, but from the power point of view, it's covered. And the level 2, it goes up to 1 megawatt, that is a step higher, and the level 3 goes up to 4 megawatt, that is 3-4 steps behind these 60 kilowatts. All of them, they are the versatility of the charger is one thing that the market is requiring to us and to all of the charging infrastructure suppliers. That means that you can use the full power in one output, one outlet, or you can, let's say, split this power to up to 3 different plugs. Okay, so of course, if you use 3 plugs, the power will be the 1/3. The market demands us to make it some compact and reduce the footprints. Nowadays, 3 outputs, each one of 60 kilowatts. So at the end, having 180 kilowatts as a whole, we are using a footprint of 800 multiplied by 800 centimeters squared, something like this. This is the all of them. They are modular. I mean, they have some the power blocks are power system. They are in, let's say, in a modular way. Okay, in order to reduce the maintenance time. As we are part of Charin, as Miriam explained you before, and we also take part in different standardization bodies at European level, we are committed, of course, with all of the interoperable, let's say, standards, as the ISO 15118.1, .2, the coming .20, and also with the standards of the charging for the EV or for the electrical vehicle charging systems, the IEC 61851, and all of these, the different .1, .23, .24. Okay, also it's important to standardize with all the solutions with the vehicle, but it's also needed to standardize the information you are exchanging with the backend. That means the backend is someone connected in the other part of the of the chain. I mean, it's the bus, then it's the charger, and then you have a backend system where all the information is collected and where the decisions are taken. So in order to talk with this backend, you need to also to fulfill some standards as OCPP 1.6 JSON. It's the more used one in the industry today. And also some added value services as BDB 261. Okay, it's just highlighting in this slide that the charger you are seeing at the right part of the slide is not just let's say it's not just a structure with a pantograph to be able to connect the pantograph over there. The charger is inside this cabinet or inside this structure. We are able to put over there up to 450 kilowatts. So there is no need of having a central inverter or central power charger located wherever. It's all installed in the same footprint. Okay, so it's where we are. Where with CCS standard, and in the moment it's our point of view on where we are with CCS and also other charging supplier infrastructures. And the next point is the MCS, how we see the MCS and in which point we are in order to tackle all the different, let's say, things that Miriam told us before. In this roadmap, we wanted to show you the 3 different levels, the level 1, level 2, and level 3. In the left part is the already existing MCS level 1 solution. As I told you before, the MCS plug, it was modified by the standard several months before, and this is the thing that we are still working. All of the suppliers were still working on that, but it's available to use it with 3 CCS plugs, and the power point of view is also very functional, and it's already been in. You can see this kind of solution in different cities as a CCS solution. In the bottom part of the slide, there is the 1 megawatt charger. This is the level 2 solution. This is the charger we are developing in this NextETRUCK project. And this is the one that we are going to make some focus on that in the next slides. Okay, we are going to talk about the different cabinets of the charger, what they are, how the procedure we use to select or to design the different elements, which topology we have used in order to do that, and the next step we are facing right now in this project about this 1 megawatt solution. That just as an overview, I will say that it's able to give 1 megawatt in 1 MCS output, or let's say alternatively, or 3 HPC plugs to supply 350 kilowatts each outlet. Okay, this is how it works. And the third level of the MCS is in the upper right part of the slide, where this is a render. Of course, we are not still design. We are still doing our first mechanical designs, and we are doing this render in order to show you how it will look like in 2027, something like that. And it will be the only one of this slide and the only one that will be with a liquid, let's say, liquid cooling. Okay, the other ones not. So in this project, in this NextETRUCK project, we have these main objectives for this level 2 MCS charger. The idea is to design a centralized power converter up to 1 megawatt that should minimize the footprint of the solution. It has, as I told you before, different multiple outputs, at least 3 different outputs of HPC, let's say, hoses or outlets, in order to be also compatible with actual and standard vehicles that could be also arriving to the charging station, and having some modularity in the product and scalability. And it has been solved using some power modules. Let's say the power modules of 30 kilowatts in this case we are using, and you can, let's say, in case of having any failure, you are not, you can still using all the other modules, and you are not losing, let's say, one branch, or neither. No, you are not losing the whole charging, let's say, outlet. The smallest output we have is 350 kilowatts in order to provide a more cost-effective solution, because we know that in not all the cases or application, the market should need 1 megawatt solution. Okay, so we can adapt and have different range of products, depends on the application. We are not working alone in this NextETRUCK project. We are leading all of the manufacturing processes, the design and of the cooling system, the power modules, manufacturing the power converter, and doing the, let's say, the control card. But from the charger topology selection point of view, and with the silicon carbide power modules that we are using, and the control strategies, VUB, the Brussels University is a partner that we work with in order to do this, let's say, tasks. Let's talk a little bit about the structure of the amount of cabinets, or how we have designed this level 2 1 megawatt MCS charging or charger. It has, as you can see here, some on a slide view of the charger. You can see 5 different modules. The first one, if you go to from the left to the right part, the module 1, it's the DC connection. I mean, it's written down battery connection. You here inside, you will have the connection to the batteries, also the protection needed in order to connect to the vehicle. Okay, in the orange one, the module number 2, module number 3, and module number 5, these are the power units, the power conversions, all the different power electronics in order to make the AC-DC conversion is inside these cabinets. Also, the protection needed in order to do this type of connection properly with safety and fulfilling all the standards, and also the connection part. I mean, the connection parts that allows you to use the full power in one outlet, or to split all the power to 3 different outlets. All is also inside these cabinets number 2, 3, and 5. And in the cabinet number 4 is the AC connection. So you come with the cables, the cabling coming from the city, the transformation center, and you make all these connections with the 3 phases, the neutron and the earth. Of course, also protection elements are inside, the control cards is inside, how the different elements in order to make it, let's say, to make the pre-charge stage of the charging processes are also in this cabinet. The second point that we wanted to highlight here is how we have, or the procedure we have used in order to select some important parameters of the power converter, of the charger. I mean, you will need to select the operation switching frequency of the semiconductors. We need to select the filters, LCL filters, so the chokes and the capacitors, the value in order to filter, to reduce the ripple, but being efficiency, not being very bulky, not being expensive. So you need to optimize let's say the design. How we make it? We have this realistic approach. I mean, we are using MATLAB, and we have some dynamic simulations that we have where we have designed the whole converter. We have used the different dataset parameterization in these dynamic simulations. We have modeled also the power losses with the conduction losses and the switching losses of the semiconductors. We have modeled thermically, we have the thermal model of the different modules, of the different elements of the power converter. And we have also made some estimation of the complete efficiency of the different parts of the converters. Having all this information into the MATLAB simulations, we have run a dynamic simulation in an iterative way until we have, with this, you can say some options. You need to minimize the volume, the losses, the price, but achieving this is the minimum values you need to achieve, but maximizing let's say the features. That means minimize or to achieve the good the ripple magnitude in the AC part, minimizing the harmonics in the AC part. So these are the minimum and maximum that you need to take into account in order to run these simulations, and at the end to select the switching frequency of the semiconductors and the passive elements that you need to use mainly in the LCL part of filter. Okay? In the AC part and also sometimes in the DC part, you need to know the capacity of the capacitance that you need to use in your systems. Okay, DC capacitors, the yellow one that we have highlighted in the image. So it's a quite complex work that it's quite demanding in time in order to make all these simulations. You need to set up this simulation and cross, let's say, check that all of them are good enough before to put them all together and run the simulation. Okay, and then you see how it works. You change whatever, and you need to do it sometimes, several times, in order to look for the optimal solution. So this work has been done. So the mechanical, in the previous slide we have seen how it looks like from the mechanical point of view, the different cabinets. In this slide, we have shown you the procedure in order to select the different main elements of the systems. In this slide is the topology that we have choose. Okay, we have looked for different, from topology point of view, different possibilities that there are, and at the end, okay, here in the slide you can see you come from a transformation center, which is this isolated transformer. It could be, or it's bidirectional, and then we need to put our LCL filters in the AC part and then convert this energy in AC mode to the DC part in order to be able to charge the vehicle, the batteries in DC. Okay, so in order to do that, there are different options, quite a lot, but at the end we decide to make a three-phase active front end, this AFE rectifier, mainly because of the THD, the harmonic distortion that is presented in the grid is minimized using this topology. So this is the main one. We didn't know how much going into details in this kind of technical explanation. Maybe if some of you are interested, you can make some questions, or even we can answer you out of this, let's say, webinar, or even it's a lot of you are interested, we can make a second webinar and go into very, let's say, detail about the topology, the power converter, the losses of the semiconductors, all the kind of stuff that is, from the technical point of view, maybe could be very interesting. And where we are right now with this MCS2 level power converter within this NextETRUCK project. we are receiving the silicon carbide modules. Here you can see our 3D step model that we do with one power block. Some of them will make one of the branch of 350 kilowatts of the charger, and three branches will make the 1 megawatt converter. So now we are doing the smart adaptive control. Of course, we have talked a lot about the hardware, but there is a lot of work also in the software. We have optimized through an adaptive control approach, providing an efficient balancing among the integrated power modules and units, and having a predictive charging events according to the eco-charging processes that we will develop also in other tasks in the project. So that means this is how this adaptive control will work with this hardware. And the next point will be the prototyping it, implementing and testing all these power modules and the charger itself in mid-2025. And this is all. If you have any question, Q&A time, we'll be glad to go deeper in any part that could be interesting for you.
Yes, there are a couple of questions here in the chat. First of all, Stephanie van Damme is working for Alice, and she's also working on the ZFS project. And she has a question: is there a list or map available of the JEMA HD infrastructure? We are looking for some good chargers for the ZFS project, trucks in Spain, France, Germany, and other countries.
I mean, in the map that Yvonne has shown at the beginning of his part, let's see. Okay.
Yes,
to explain this, what I know from the ZFS project by heart is that they have pretty much defined routes, so therefore they would need to have more precise information than 729 charging points in Spain, for example. So, but
Sure.
I mean, in case you don't have that available on a homepage, I could also connect you both, and then you can exchange via email. That's also possible.
Sure.
Yeah, sure. We have some products available, and we need to fix if these requirements of this project it's close to them or not. I mean.
Okay, great. Lukasz is asking, will the cabin or the one that you see in your background, Yvonne, basically, will this be placed outside or will it be used inside the building or a container? And what is the space required for it? The dimensions, basically.
Which one? Excuse me?
Yeah, or the ones that you're showing in the presentations. Yeah, one of those. I mean, are they normally built for outdoor use, or should they be inside, or what's the situation?
Depends on the project. I mean, it could be both of them. We have the indoor solution if you are using in a already existing building or in a transformation center or whatever, and also, but most of our designs are outdoor, are IP54 for outdoor solutions prepared. And the dimensions, by heart is 800 centimeters.
Yeah, it's
length each one, so mean around 4 meters.
Yeah, that's it.
Okay. Perfect.
2 meters tall and 1 meter
less than
wide.
1 meter wide.
Yeah. It's more or less the footprint. It's not necessary to use the 5, let's say, columns in all the projects. Depends on the power you will need. Of course, the AC one connection and the DC one is always mandatory, and the number of power modules or power cabinets depends on the number of outlets you wanted to have and the power you need for your application. So it's quite modular, this design.
There's a further question from Scott that he stated earlier. He was not, when he was asking the other question, he was not referring so much concerning the electrical design, but more the overall design, such as hardware, footprint, accessibility, cable management, and all of this. Do you see that there are, or maybe there's also an additional question from my side. Do you see any problems with the setup that you're going to use or test with regard to significant outdoor, let's say, temperatures, or are there any bottlenecks, for example, in the developed design? So for example, could this also operate in Norway at minus 10 degrees, for example, or yeah.
Yes, there are some ways to do that. I mean, of course, if you use a indoor solution, it goes in a already existing building, and you can. So there's no need on that, and it's if you are using the outdoor solution, I think that is up to minus 10 or
minus 20 degrees.
minus 20 plus 50.
Yeah, something like that. Of course, we have some internal heaters so that all the internal elements work in a more comfortable temperature, not in a so cold. So it's just putting more or less heaters inside.
Yeah, of course.
Which also means that you have more standby power consumption.
Yeah,
but of course, you can't have it all in this case.
Okay.
And let's say access footprint and cabling and everything. We try to, let's say, as we work in JEMA has a great experience, or a big experience in power electronics, different sectors. We try to apply what we have learned from all sectors in all of our products. So we try to, let's say, ease the connections and the footprints to the local constructors and everything. Give them enough space to work inside our products. Work with big or small cross-section cablings, putting more cablings per pole or less. That depends on them, how they work more comfortably. Let's say we are quite an flexible company in that area. We try to work and find that the best solution for the customers.
Okay, perfect. Since it's nearly 11 o'clock, and I will forward you the contact details of Stephanie from Zephys or Alice.
Thank you.
I would like to wrap up the this webinar and share with you our social media information, where you can also get in contact with us, basically. So let me share my screen. You should be able to see it now. So this is very brief, basically. It would be good if you could connect with us, because at the moment we have basically NextETRUCK has basically finalized all of the main pilot outlines, and now the pilots will start. The first one which will start will be the one in Barcelona in late Q1 2025, so around March probably. And we also want to organize an event in Barcelona, which we are currently starting to organize. So whenever there's more information or first save the date, you will find this information, of course, on our social media platforms, which you can access through the QR code, obviously. We have LinkedIn, where we are very active, and Twitter as well. And our homepage is nextetruck.eu. So basically, whenever we have new deliverables or events coming up, you can find all of this information on the website. And we are also currently planning further webinars related to other topics of the research related to NextETRUCK for early next year. And so whenever we have further information and dates, we will, of course, as I said, publish it there. So yeah, In case you have feedback or suggestions for further topics, please let me know. My email is nschmalholz@polisnetwork.eu. And with this, I would like to thank my colleagues from JEMA, and I hope you had an interesting time, and we will hopefully see you next year for further webinars. And yeah, thank you very much, and bye-bye.
Bye.